water. It's our life source and we're expected to look after it. By 2027, the European Union expects all water bodies to have good ecological status. But the Environment Agency of England and Wales estimates that around 30% of water bodies are currently failing due to agriculture. Agricultural soils contribute approximately 60% of nitrates, 25% of the phosphorus and 75% of the sediments that enter our water bodies, with a resulting impact on ecology and public water supply. The enrichment of waters due to nutrients is called eutrophication.
My name's Phil Haygarth and I'm Professor of Soil and Water Sciences at Lancaster University in the UK. Nutrients are essential for our food production, but they also cause us problems. I'm going to show you how nutrients can leave farmland and make their way into waterways. You'll learn about the central role that soil plays in processing this, and I call this journey the transfer continuum. Let's start that journey.
In order to meet the demands of normal modern food production, farming needs to use fertiliser nutrients, nitrogen and phosphorus, to enhance crop production. The farmer makes a choice about how much to apply to the land, which is supposed to match the crop demand. If the input exceeds the crop demand, it will accumulate in the soil. And if this continues in the long term, the soil accumulates nutrients.
Nutrient sources can also come into the farm via feed concentrates like this that are fed to livestock like these dairy cows. And because their dung and their manure ultimately ends up in the soil, these nutrients also need to be accounted for as part of the farm nutrient balance. So the sources represent a potential reservoir for onward transfer through the continuum to the next step, mobilisation.
Mobilisation describes the start of the journey of the substances as they leave the farm. The soil is the central processor for this. There are three types of mobilisation.
When soil is bare, either through tillage or through trampling by livestock like this, it's very likely to become washed away or eroded. When the soil becomes compacted, the rainfall that hits the surface is more likely to channelise and therefore entrain particles. When this happens, we call it mobilisation by physical detachment, the actual removal of soil and sediment with nutrients and other potential polluting substances attached. A second form of mobilisation is called solubilisation, and this involves the leaching of nutrients by chemical and biological processes from within the soil. Chemically, when soils exceed their sorption capacity, they can actually release nutrients more likely into solution. But there's also biological processes called mineralisation, which also release nutrients into soil. The interplay between the biology and the chemistry is complex, and there's a very fine line between mineralising enough nutrients so that the crops can get what they need and not solubilising enough nutrient so that it leaches off to water.
A final and easily overlooked form of mobilisation is when fertiliser or manure is spread on the soil surface but gets washed away before it has equilibrated into the soil. These are called incidental losses. The third part of the journey is called delivery. This is the part that connects the mobilisation from the soil to the river. Delivery involves substances being washed across or through the soil with flowing water. When the surface is impermeable, often with depressions or hollows, overland flow pathways develop, which can come and go depending on the intensity of rainfall and runoff, as well as the nature of the soil surface.
It's easy to forget that as well as over the surface, delivery can also occur through the soil, perhaps through cracks or macropores, or through the permeable geology underneath. Finding a solution to the problem is not easy when the effects on rivers, lakes or estuaries might be many miles away and many years later than the start of the journey.
Here in the River Eden Valley, We've started a long-term monitoring programme to study the nutrients in the river and work with local farmers to find solutions together.
So we've been taking some samples, there's some equipment in that box takes samples every 15 minutes.
This involves thinking about reducing sources to match crop demand, accounting for the fertiliser value of manure, and mitigating the detachment of soil or the solubilisation of nutrients. Here is an example of where we have installed some mitigation features to help slow down the delivery, effectively through trapping the flowing water so sediment can settle out.
If we're to meet European standards, we need to adopt the holistic source, mobilisation, delivery, impact continuum model and recognise the central role that soil plays at the heart of this. This will give us the best chance to maximise food security and minimise the effects on water quality.